Hello folks, well it's Saturday, I've got a wedding to play for today, and so I'm only going to put half an hour into this as I planned. There's a lot of practice has to go in, all these things have to be absolutely spot on, as you can well imagine. To that end I've been printing the hymns out onto yellow card. One of the problems is if you've got 2 pages, I've got Jerusalem to play, in other words, and did those feet in ancient times, it's on 2 pages. And one of the problems is you can't be turning pages over, the music's too complex. So you're printing, you can't be playing from a hymn book because you're going to need 2 hymn books because it's on 2 lots of pages. So we print these out onto yellow. I do have colour blindness to some extent and this helps me no end. And of course I've gone and left yellow paper, or its card, in the printer, which is about 15p a sheet. And I've gone and printed today's job sheet out on the yellow card. So, it's the 9th today, I know that, 9th of August 25, Rotel RVC220 and 201-21279. So this is donation So, this is supposed to be a screwed up set, and it's been donated, and if I can get this to work, and if our pal can, I think he's done some knobs for this. This was one of the ones featured on the unboxing. So there were 3 sets from the same person. There was a chassis for a Barracuda, there was this, and then there's a Midland Porter Pack. So this is the kind of middle one of those. And while I'm kind of set up for Cybernet, I may as well do this before working on the Moonraker handheld, which is going to take some thinking about next time we do one properly. It's got a broken socket for a start. So tomorrow I've got 4 church services to play for, so I don't think we'll be doing any CBs then, so it'll probably be back to Monday. But I'll give this a go. It'd be nice to get an on-the-air test, seeing as Mr. Chippie will be here later on. Right, so we're powered up, 13.8 volts, the radio's come on, channel 20, I'll just see if there's some kind of odd knob on the bench which doesn't belong here. Plug our standard test mic in. So we're on channel 20. I've got no secondary cameras. I'll just go and see if the box is powered up. Well, it seems to be on now anyway. Right. So we're on channel 20, we've got the test gear plugged in. Let's put 100 microvolts on. It's not receiving 100 microvolts, and we're going to, I'll put picture in picture on, we'll go to the main meter, we will go into transmit, and we have no transmit. So, see if there's anything we can do with it. Has it been messed with? Has it had its phase lock loop chip ruined? Or is simply the 10.24 crystal knackered? It's clearly a set that's had a lot of use. I've got my aerial thing in a twist. I'll just slacken that off. We'll end up with a snap cable. Pop that off. Well, I can't see anything silly on this side. Just plug our... I'm not going to plug the test gear in case it's putting out volts. I'll plug in the extension speaker. It sounds like the audio is being strangled by a possible short circuit to some extent. I'm just feeling the audio acid to see if it's getting hot, and it's certainly getting warmer than I would expect. Just pop the other lids off, just in case there's something silly underneath. But I don't think the fact there's no phase lock loop operation is anything to do with the strangled audio. What's happened there? Oh dear. So it's had the phase lock loop chip changed. There's a possibility it's been turned into a legal 80 channel modification, then reversed, and then it's, of course, because the set's already been blown up, the reversal hasn't worked. You see there's a link out there which has been overlooked and covered in wax. Right, let's turn it off. I've already seen the brush, it's on the floor. It still doesn't account for the audio, but you never know. Right, so first of all we'll put a bit of wire in which has come out of the handheld, which you haven't seen yet. So they've cut, yeah, it's had the illegal 80 channel mod, and so they've cut this, so we need to reinstate that. Might just put a wire link in there. Also need to solder that up a bit better. Potential dry joint there. Good. So we'll just put that link in. Use a bit of this wire. So they covered the fault in wax. I have every faith. Turn it back on. Well, it doesn't work. But of course the VCA may have been played with. Let's get the meter on the job, go to channel 40. And of course the phase lock loop chip could be ruined. So got 0.4 of a volt. Well, that's certainly not normal, is it? Let's go into transmit. So we've got no transmit, no receive. So and of course this VCA is not doing anything. Alright, I'll have a look at things and we'll pause the video. Okay, just an update. So I've taken out the phase lock loop chip, which I can't get the oscillator reading for the crystal. I took the crystal out. I've put any old crystal on the other side, well, any old 10.24 crystal which we've recovered out of another set. By that I mean one that won't go on frequency, but at least I mean you know that it's going to oscillate. So we'll put a brand new synthesizer chip in. When I got these, they were $16.99 each from a authorised source. It's alright saying you can get them for 50p when they're fake. did this with the solder sucker and desolder braid. We lost a bit of the track there, but it's the it would be channel 9 if this set had that feature. I'm just making sure it actually fits, because the spacing can be interesting. Quite difficult to get in on these sets without dismantling all the channel selector, but we will. Just like that. Now, where did I put my solder? Potential dry joint there. It's possible it's had an illegal 80 channel modification, and somebody's reversed that, but the phase lock loop chip had already been killed, which quite regularly happens with that modification. I won't buzz those through yet. If there's a snag, we'll go through with the multimeter, but I'm wanting to move away from this and put my mind to the organ today. So power this back up. We've still got the bodge crystal on that side, so I better just prop this up a little bit so we don't crush the crystal on the other side. I'll borrow these pliers and just hold it off the bench. So switch on, see whether we've got any voltage joy. Yes, we have. Look at that. See if we can do transfer. I don't think it's working still, but that's it's certainly heading in the right direction. So we've got logic high instead of low. I'll tell you what I'll just do. I'll put the crystal back which came out, and we do have a crystal tester, but it means finding it. Kind of hold that. I've not put that wire on, have I? The white wire. I've not put the white wire on that somebody had to put in to link the track out. Where's my solder end? That'll do. That's the one we're talking about. I'll tell you what, we'll just buzz these through, because I mean, that's clearly going to be the problem now. Right, let's just buzz these through. There's only 20 to do. One, 2, 3, 4. That's the one I put in. 5. That's the one they put in. 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18. We know that's open circuit. It's the channel 9 one anyway. So there we go. Actually, I'll put that back on because we're going to need it, aren't we? Switch it back on. We're on channel 40. See whether we can get receive now. I've put the link back in. Ah, that's a bit different, isn't it? Now that's set up on receive. Let's go into transmit. So we want 4. What am I doing? It's supposed to be the trimmer. So we've got 4 volts now on transmit. We haven't got transmit, but it might have got a blown up transmitter. So we've still got 4 on receive. We've got 4 on transmit. Let's do the checksum. Go to channel 1. Yep. And on transmit, yes. Right, we'll go to channel 20. We'll probably get receive now. Unless, of course, we've got a dodgy aerial socket. Just make sure that's tight. You can hear it trying, can't you? I mean, there can be a dry joint on the channel selector, which is frustrating when we've I've able to set it up on 1 and 40. It's already been soldered about 10 million times on here, so I've already and I've lost the solder. I'll just reflow these without using any solder then. Let's try joint. I can't actually see a pin there. I think the channel selector switch has got a pin snapped off it. All right. Well, come to that. But whatever the dry joint was, I've cleared. The question now, we're still not going to have any chance. Oh, we have got some transmit. Perhaps we're on low power. Yep, that's dirty. There we go. We've got transmit. Let's put our walkie-talkie on. Pop it down to channel 20. Testing 1 2, testing 1 2. So, out of interest, are we anywhere near on frequency? It's actually high. Let's put that somewhere near. And it's doing 3 watts, and just we'd roughly look at where we are with the receiver. We're on 100 microvolts there. That's 0.3. Not sure we get all the channels. I might have a faulty channel selector switch, which would be great fun because you've got to take that board off and you know all that. Anyway, I'll come back to this after church, but so far I've spent 40 minutes and £16.99 on a chip. Okay, so it's 6 o'clock now and we'll get back on with this and treat it as a straightforward retuning test. Now we've actually done the BCO, nil, now it's 4 plus 4. Let's check where we are with the frequency. 2779139. So there wasn't a before on that because we couldn't read it. Channel 20, 3.1 watts. Channel 40, 1.8 watts. Let's put the other meter up. Channel what? Sorry, I was. Did I put channel 40? Yeah, I did. And that is 3.4 watts. Well, that's been messed with, hasn't it? Back to channel 20. And our low power is 200 and... oh, it's jumped to 300 milliwatts. That tells me that the preset's dirty that did that jumping around, so we'll deal with that. That can be soaking in. Give it a twiddle. And our current consumption for full power is 994 milliamps. Receive. Let's put the cyanide meter in. We'll need an earth. I don't think that one works, does it? The green one doesn't work. We'll need a sufficient waveform for the AGC to be right. And we'll go to the cyanide meter. We're at 1 microvolt. Oh, it's very good. It's 0.28. 12 for 10, sorry, 0.23, and for 20, 0.42. Squelch to full. Let's put the attenuator up. If you can see it beyond all these wires. So I want it to open at 100. 310, 30, 100. It is opening at 1.5 millivolts. At least it opens. And the other end, we'll park it at 0.3. Set squelch. Signal generator on. 0.51. Meter, 100 microvolts on the signal generator, and it's not quite there, so what do we have to do? We actually have to go to 1 millivolt for 100 for S9. Turn the volume down, and on transmit the meter. Better remove the earth. It's actually bang on the 4, even though it's doing 3. But that's how it's supposed to be set. Right, let's get through this transmitter. Move that meter. Our friend who does 3D printing for us in Leeds has very kindly found me in L11 off a scrap chassis, was it L11, for that low TX40. So we've solved that problem, and I do thank him for doing that. So that's good. Means he's also taken the heatsink off his scrap chassis, which means that my PT40, World Sound PT40, it should now be complete, and so it can be repaired. Well, apart from putting a new audio chip in, which is missing, but that's fine. Right, going to transmit, channel 20, here we go. See if we can get more than 3.1 watts out of it. So we want the centre of the peak, which is there. That was actually about right. We know something's not right because it's well out of balance. So far these are all right. perhaps that not. Right. So once again, these go temporarily to maximum. That was already at maximum, it's doing 3.1 watts. It's now doing 4.05 watts. It's now doing 4.4, so just go through these again very quickly before we melt the radio. Right, so because it's warmed up, we've now got the situation where it's gone to about 4 watts. Actually, it's gone back to 4.5. So we'll set this to 4.4 clockwise. So before legality side, never leave these at full whack. It's not designed to do that. It's designed to be doing 3.8 watts, but we're going to do it to 4. So that's clockwise for 4.4. And then this is anti-clockwise, they say for 3.8, but we're going to have it at 4, which is there. Right, so we've now got 4 watts on channel 20. So check the other channels. It's fun with that a lot. 3.9 watts on channel 1. 4 watts on channel 40. Oh well. 3.9 watts. 4 watts. When that cools down, that'll be probably slightly over. And the current consumption is now 1.178, which is where we'd expect it to be. Low power. Hopefully we can set that now to 400 milliwatts. So there's 400 milliwatts. Let's do the deviation right now. Wow. Oh, looks like that is it's 3.5. Well, that to the central position. It's actually at full. How daft is that? I wonder how many channels at once we can talk on. Right. So it was 3.5, it's now 2.2 to 2.5. Nil. Set the power meter. I don't know where I've put the trimming tool, of course. That's up there. Right, see what the meter says now. Oh, we're on low power, aren't we? There we go, that's set. Receive. So on the face of it, not very far out at all, but we still have to go through it in its entirety. Have we got no yeah, got no earth on it, have we? Right. So 100 microvolts on the signal generator. Let's put that oscilloscope up. Absolutely spot on. I'm going to do the IF next. I want to look at the meter on the front, as well as the oscilloscope and the cyanide meter. We'll put the cyanide meter up on the inner picture. Just go through these. The one hidden under the wiring harness doesn't usually get messed with. No, it's spot on. That was spot on. This can sometimes, let's have a look. Let's put a smaller signal on for that. And then we'll do the two front ends. Probably only gained on that one. I can't think there's going to be any difference. It was already very good, but we'll see. Here we go. 12 dB cyanide, 0.25. Ten dB, 0.22. 20 dB, 0.38. Squelch to full. I want it to open at 100 microvolts. I've got the signal generator at 100 microvolts, and we'll need to adjust the squelch control till it comes in. And then whilst we're on 100 microvolts, we'll set the S meter to read 100 microvolts for S9, which it does. Check the squelch. Squelch to threshold. Signal generator is in standby. It's parked at 0.3 of a microvolt. Here we go. Straight in at 0.3. Got to check the power socket on this. There we are done. Now I had two concerns. One's the power socket. I'll just disconnect the mic. I need to go over this with isopropyl alcohol. It's just that I can't see anything wired to that. I'll do the isopropyl alcohol. The person who gave us this set said it was one of his father's spare sets. It certainly wasn't going to be doing anything, was it, without intervention of changing the phase lock loop chip. But, I mean, you know, they were $16.99 when I bought them, and you know, it's not the most expensive repair you could think of. I have to check this on every channel because of my concerns with the channel selector switch. Just got a couple of potential dry joints. Just switch a soldering iron on. Come on, soldering iron. I'm just going to put a piece of wire down there. See whether it's dried up enough to work. Just take the that out and put the extension speaker back in. Put the mic back in. Right, well this is going to be laborious, but I'm going to have to check every channel. Channel 21. Let's put the squelch on. So 21. Test 1, 2. Channel 22. Let's put a screwdriver in this where there should be a... No, it's not going to work. 23, 24, 25, 26, 27, 28, 29, 30. I think we'll leave it at that. Put the lids on. Just put a couple of screws in for now. That sounds like it still works. Put a couple of screws on this side. So labouring £16.99. Squelch for a moment. Put the aerial in. And before I do that, there's a possibility that we've had some mail from our pal who does the 3D printing. He may have 3D printed me some knobs. So put that on 19. The burner brigade are out, aren't they? So I'll just pause the video while I go and have a look in the mail. So he's done me some 3D printed knobs. Let's put them on this. And a 3D printed mic hanger for that. '76, you know the one I mean. So, which we were given. So I'll put those back in the packet. They look great, don't they? There we are, 3D printed knobs, and that's not my power. Oh, that's the other thing which we need to address, but we'll do the on the air test first. That's the power connector at the back. Right, so there we go. Thanks for watching the donated Rotel RVC220. We will be selling this on in due course, and the bidding will start at the repair service work cost price, plus 1 penny. So thank you for watching the Rotel RVC220 Cybernet 134 set from 1981.